Today we'll be talking about using the quadratic formula to solve quadratic equations. So when we look at this y equals ax squared plus bx plus c, we know this is a quadratic equation because it has an x raised to the second power. So if I wanted to solve this equation, if I had values in for a, for b, and for c, then I would use the quadratic formula. The quadratic formula is x equals negative b over 2a plus or minus the square root of b squared minus 4ac, that whole quantity, over 2a. So when we're using the quadratic formula, the only time that I'm allowed to use it is when my equation is going to be set equal to 0. If your equation isn't set equal to 0, then you are going to need to manipulate it so that it is equal to 0. And we're going to see that in our first example on the next slide. So in this first example, we can see that our equation isn't set equal to 0. So the first thing I'm going to need to do is manipulate that equation so that I can make it equal to 0. And I'll say x squared minus 2x equals 8. So I want it to equal 0, so what I'm going to need to do is move this 8 to the other side of the equation. So I'm going to subtract 8 from both sides. Now that negative 8 is underneath that negative 2x, but we know that they're not like terms, so we can't combine them. So what we're really going to be left with is x squared minus 2x minus 8 equals 0. Now that my equation is set equal to 0, now I can solve. So the first thing I'm going to do is look at each of my terms to figure out what is the value for a, b, and c. So I know by looking at the general form on the previous slide, which was y equals ax squared plus bx plus c, we know that the coefficient of x squared is going to be my a term. So when I look at my equation here, there is no coefficient of x squared, so in this case a is going to equal 1. Then I have to look at my b term. So I know the coefficient of my x term is going to be b. So in our case, our b is going to equal negative 2. The constant, or the term that's by itself with no x, is going to be my c. So in our case, c is going to be negative 8. So now that I have all of my values, I can go ahead and plug those into my quadratic formula. So it'll be x equals the opposite of b. So if I'm looking at my b value, I know that that's negative 2. So it's going to be negative 2, which is really positive 2, over 2 times a. So in our case, a is going to be 1. Keep going. We have plus or minus the square root of b squared. So in this case, our b is negative 2. I'm going to encourage you to put parentheses around your negative 2 here, because if you just type in negative 2 squared in your calculator, it's going to tell you that the answer is negative 4. And we know that when you multiply negative 2 times negative 2, you're going to get a positive 4. So it's really important that you keep those parentheses so the calculator understands that you want to square that whole quantity of negative 2 and not just the 2. So continue with our formula, minus 4 times a times c. So again, a is just going to be 1, and in this case our c is going to be negative 8. And that whole quantity is going to be over 2 times our a, which is 1. From here we just need to simplify. So when I simplify my first term, it's 2 over, and then 2 times 1 is just 2. So plus or minus the square root of negative 2 squared, which we knew was 4, minus 4 times 1 times negative 8. So we got to keep in mind that negative times a negative is going to give me a positive. And then 4 times 1 is 4, times 8 is 32, over 2 times 1 is 2. So we'll keep going, and we're going to say x equals 2 over 2 is 1, plus or minus the square root of 36 over 2, and it's that whole quantity square root of 36. So that becomes x equals 1 plus or minus 6 over 2, which is 3. So the first answer would be x equals 1 plus 3, and the second answer would be x equals 1 minus 3. So my two solutions would be x equals 4 and x equals -2. So in this case, we're going to have two solutions. You can see up in the right-hand corner, I have a picture of the graph of x squared minus 2x minus 8. And you can see that that parabola crosses the x-axis at both 4 and at -2. That's really what we're solving for, is where the graph is going to cross that x-axis when we set it equal to 0. So let's try another equation. This time around, we have our equation already set equal to 0, which is great. So all I really need to do then is go ahead and figure out what my values are for A, for B, and for C. When I'm trying to find my values of A, B, and C, I again have to look back at my original equation, look for the coefficients of x squared and x, and see what my constant term is going to be. So in our case, our A equals 1, our B equals -6, and our C equals 9. So from here, we can go right ahead and start plugging our values back in. So if I'm looking at the equation, I know that B is -6, so the quadratic formula says negative B. So that's -6, which is really a +6, over 2 times A, and again, we know that A is going to be a +1, plus or minus the square root of B squared. Again, I'm going to encourage you to include parentheses around any values of B that are negative, just so that way when you put it in your calculator, if you need to do that, it's going to give you the correct answer. Minus 4 times A times C. So again, A is 1, and in this case our C is going to be 9. So we're color coding it so that you guys can follow along and make sure that you're plugging the values in the correct places. So this is really over 2 times A, which we all know is 1. So from here we're just going to simplify again. X equals 6 over 2 times 1 is 2, plus or minus the square root of -6 squared is 36, minus 4 times 1 times 9. And it's -4 times 1 times 9, which gives me -36 over 2 times 1 is 2. So looking at that, I know that's going to be the square root of 0. Square root of 0 is just going to be 0. 0 over 2 is just going to be nothing. So this is going to come down to 6 divided by 2, which is just 3. So in this case, if you look at the graph in the bottom left-hand corner of the screen, you can see that there's only one place that this graph is going to hit the x-axis, and that happens when x equals 3. So this is a situation where you're only going to have one solution to your equation. In our previous problem, we had two solutions. So let's try another one. So again, we're going to do the same exact thing every single time. We're going to try to figure out what our values are for A, for B, and for C so that we can plug them into our formula. First thing we'll check is that the equation is set equal to 0, and we see that it is. So then I have to say, okay, well, what is my A value? In this case, the coefficient of x squared is just 1. When I look at my B value, my B is going to be a +4 because that's the coefficient of my x term. And my C value is going to be a +5 because that's that constant term, that number that doesn't have an x with it. So from here, it's just all about substitution again. We would start off by saying x equals the opposite of B. So in this case, our B is a +4, so it's going to be -4 over 2 times A, and we know that A is 1, plus or minus the square root of B squared, so that's 4 squared, and you can continue to keep the parentheses around it if you want, just to have it the same every time, but when it's a positive, it's not such a big deal, minus 4 times A times C. Our A is 1, and our C is 5. That whole quantity over 2 times A, which is 1. So we're going to start simplifying again. X equals -4 over 2 plus or minus the square root of 4 squared, which is 16, and then we have -4 times 1 times 5, and that gives me -20. That whole quantity over 2 times 1 is 2. So now I've run into a problem here. If I'm looking at this square root, I can tell that 16 minus 20 is going to be an issue. So let's start with negative 4 over 2 gives me negative 2. And if I had plus or minus the square root of negative 4 over 2, I can't take the square root of a negative number and get a real answer. So what that would tell me in this situation is that there's no solution. That happens when you have a graph that doesn't touch the x-axis. When I set it equal to 0, it says that that's not a possibility. So if you look at the bottom left-hand corner of the graph, you can see that it does not ever touch the x-axis, so there's not going to be a solution to this problem. So let's try one more here, and we're going to try one that has a coefficient of a that's not going to be 1. So we're going to have the same steps over and over again. So let's try to find out what our values are. So a equals the coefficient of x squared. In this case, that's going to be 2. B is the coefficient of our x term. In this case, it's going to be positive 7. And the c is going to be that number that's sitting there by itself, and that's going to be positive 3. So then I'm going to go ahead and I'm going to substitute. X equals the opposite of b, so it was a positive 7, so it's negative 7, over 2 times a, and in this case our a is 2, plus or minus the square root of b squared, and again, you can keep it in parentheses, and then put our b inside those parentheses so we can square it, minus 4 times a times c. A is 2, and c is going to be positive 3. That whole quantity over 2 times a, and we know that a is 2. So from here we just go ahead and simplify. X equals negative 7 over 4 plus or minus the square root of 7 squared is 49. Negative 4 times 2 times 3 is going to give me negative 24. That whole thing over 2 times 2 is 4. So we'll keep simplifying. X equals negative 1.75 plus or minus the square root of 25 over 4. So I know the square root of 25 is going to be 5, so I could really rewrite this as x equals negative 1.75 plus or minus 5 over 4, which is going to be 1.25. So from here, again, I have to break it up into the two different equations, and I'm actually going to move this over here so we have some space to write out our work. This is going to be x equals negative 1.75 plus 1.25. And this side will be x equals negative 1.75 minus 1.25. So our solutions to this problem would be x equals negative 0.5 and x equals negative 3. And again, if you want to check out that graph, you can see that our parabola is going to cross the x-axis at those 2 points. So whenever you're using the quadratic formula, it's the same basic steps over and over and over again. It's really just important that you can identify your a value, your b value, and your c value, that you're careful when you're multiplying, and that you're including the negatives in the right way, and that you're always making sure that your equation is set equal to 0 before you start using the quadratic formula.